So this should be solve for x or y. So that's always going to be your first step. And then you're going to substitute whatever expression you solve for into the equation and solve for the variable. And then you're going to substitute your answer into the equation from step 1 and solve for the other variable. So it's a lot of substituting and solving. Also, before we continue, go put your phones up. If you have not already, go put your phone in those pockets, not in your pockets, not in your book bag. Because if I catch you with it, it's mine until the end of class.
That means you too, Alex.
I got my Christmas work too fast.
Word. Alex.
So you can put your phone on too.
I'm just gonna get it in like 10 minutes.
That's fine. Put it back.
That's some-
Oh, she's sorry. Wait, how should I say the way? Oh, sorry. Wait, I thought she was delayed.
Alright, so for these types of problems, and this is like intro to what we're actually going to do. So this is one way to solve our systems of equations. So remember again, that's just multiple. So if you're given something like 1 or 2, where you have some variable that's already solved, like this one's solved for y, this one's solved for x, you can use that, and then you don't really have to solve for one of the equations, it's already done for you. So you're going to take that equation and put it in anytime you see a y, into the other one. Not into the same equation, but into the other one. So in the second equation where I see y, I'm going to put x plus 9. Since y equals x plus 9. Anytime you substitute one equation into the other, whatever variable you were starting off with disappears. That way you can combine like terms. That should always happen. So now we're just solving this for x. So we need to do what here? Distribute. So 8x plus 72. I feel like that's not right. And then do what? What are our like terms?
3x and 8x.
Okay, so when we combine those, that would be 11x. And then
Combine 72 and
combine them how?
subtract 72 on both sides.
So combine them really by moving one to the other side. So 11x equals what? Negative 77. What does x equal? Negative 7. That is just one part of your answer. You have to find both x and y. What does x equal? What does y equal? To find your actual answer. If you just find one part, you only found half of the answer. So now that we have x equals negative 7, you can do one of two things. You can either put it back into the equation where y was set equal to itself, or you could put it back in here and solve for y. Either one, you're going to get the same thing either way. I'm going to go ahead and put it in here. So if I put negative 7 in here, what is y?
2.
2. So really, each of these has an x equals and a y equals because your answer is really in ordered pair. That is really your answer. Negative 7, 2. We talked about solutions a while ago, like maybe at the beginning. We talked about that solutions are usually your answers and makes them right, things like that. Well, with our solution, because we have a system, we have more than one equation, these two numbers have to work for both in order to be a solution, or it doesn't work. So if I put in negative 7 in for x and I put 2 in, I know that worked because we just saw that y is 2. If I put these two numbers in here, do we get negative 5? If you put negative 7 and 2 into x and y, do you get negative 5?
Yeah.
3 times negative 7 is
Oh, yeah, you did.
negative 21. And then 8 times 2 is 16. Negative 21 plus 16 is negative 5. So these solutions have to work for both if it's going to be a solution. I'm not going to do all of these because I want you guys to try some. Let's do one like 3. So for the most part, you'll see equations that look like this. Are either of these equations solved for x or solved for y? And number 3. And number 3. No. So that means we need to decide, are we going to solve for x or are we going to solve for y, and which equation do we want to use to do that? So you guys choose. Okay, why did you pick this one? Right. So that's the easiest way to go about doing this. Look for something that's already by itself. Look for a variable that's already by itself in one of the equations. How would we solve this for y? Subtract 2x on both sides. So y equals 9 minus 2x, or y equals negative 2x plus 9. Does not matter which way you write this. Just to recall from earlier units, one is in slope-intercept form, one is not. But in this case, it doesn't matter. Or in this unit, it doesn't matter. So now that we have y by itself, what can we do with that equation? In the first. So we're going to put one of these two back into the first. Remember, it's always the other equation, not the same one you just solved. If you do that, you're more likely to get the same answer. And you don't want that. So because y equals this, I can say that y is now 9 minus 2x, or negative 2x plus 9, whichever way you're writing that. But don't forget to put your number at the end, so this one equaled negative 11. And then same steps, distribute, combine like terms, solve. So this is negative 3 being distributed. So 2x minus 27 plus 6x. And then if we combine our like terms, what would that give us? $8x. if we add 27 to both sides, what would that give us? 16. So what's x? 2. But remember, you're not done. You still need to go back and find y. So because we changed this equation, you now have even more choices. You can put 2 in here and solve for y. You can put 2 in what you solve for, or you can put 2 into the original. Either one is going to give you the same answer. I'm just going to go ahead and put it in this. What is the value of y? 5. So our ordered pair here is 2, 5. Just to check to make sure this works for both, because it's not a solution if it doesn't. 2 times 2 is 4. Negative 3 times 5 is 15. 4 minus 15 is negative 11. That works. 2 times 2 is 4. 4 plus 5 is 9. That works. So if only one of them worked, that would not be your solution. Something is wrong. So I would always double check. Make sure that your answers work for both. Do we have any questions right now? Yes, Alice.
Are we allowed to put x in?
For
Are we, for number 2, x equals 4y plus 7, can we do 2 times 4y plus 7 or no?
yes. You can solve for either variable. It does not matter. We weren't together. I was going to let you guys try 2 and 4. We're going to do more after this. But go ahead and try 2 and 4, and then we'll come back and talk about it. And if you're still working, you can finish, and then just make sure you check your answers with mine. So, with number 2, did we have to solve for an x or for a y? No. Because it already had one solved by itself. So what would we do with that? Put into the other one. Ian, put your phone on the desk, please.
My phone's running out. So I went wrong.
So we're going to put that into 2x, or into x. So I know one thing that I saw a lot of is that many of you were putting this here. But the only reason we were doing that here is because we had y equals. So be very careful that you're not putting that in the wrong place. And then solve just like we were before. 8y plus 14 minus 6y equals 12. And then combine your like terms, but be careful that you're not doing the opposite, same side, same operation. So subtract. And then we can move 14 by subtracting. So what did y equal? -1. And then we can go back and put that in for x, or into our x equation to solve for x. So -4 plus 7 is 3. So our equation, and be careful because we solved for y first, our ordered pair should be 3, -1. So these are still x, y, no matter what you solve for first. questions on that one? Now with number 4, let me ask the same question. Do you have to solve for an x or for a y? Do you, or are they already by themselves? In this one, they're already by themselves. But we have 2 of the same variable by itself, so it's a little different. Because these are both y equals, you can do this one of 2 ways. I can either put this for this y, or I can put this for this y. Either way you write it, the 2 equations are going to be set equal to one another, and you're going to solve. So if you get something like this that has the same variable solved for itself, you're going to set them equal to one another. And then remember, with types of equations like this, you pick and choose what you want to start off with. So what do we want to move first? Okay, so we can move to 1. Which will leave 4x equals 2x minus 4. Well, now we have to get our variables to the same side. So we have to move 2x. And again, if that's not the way you solve that, there are 4 different ways to go about it, so it's okay. What does x equal? -2. Now that we have x, we can put it in either equation and solve for y. It does not matter which one. So -8 minus 1, y is -9. If we put it in the other one, -4 minus 5 is still -9. Either way, -2, -9 is your answer. So really, there are 3 different ways to solve systems. Most of the systems you will see, especially on the SOL, will be word problems. So we're going to get a lot of practice in with those today and throughout this unit. If you can't see the words on yours, they are going to be up here, so you can read it off of this. I think you have a blank sheet of paper at the back, so that is extra space for you to do your work on. If you want more paper, you can come grab some. But we're going to work through these until we run out of time, basically. So for each of these problems, what is the very first thing we need to do with word problems when we read it? Underline, highlight, circle, whatever that's important. So I'm going to read it first. At the movie theater, the Clayton family bought 4 fountain drinks and 3 bags of popcorn and paid $22.50. The Hanks family bought 5 fountain drinks and 2 bags of popcorn and paid $23.75. How much is a fountain drink? What's important here? The amount, so the cost. The amounts of food and drink. So 4 fountain drinks, 5 fountain drinks, and then the bags of popcorn. That was a terrible color.
Can I get Ethan Wiley?
These are my first year class.
Alright, thank you.
Can you do this last class? they came to like the same period. It may have been fourth grade that they asked that. Okay. And then anything else important?
How much is the fountain thing?
How much is the fountain drink? So we need to know what are we looking for. So in these types of word problems, they're looking for just one specific answer. But that's not always the case. Sometimes they're looking for how much was the fountain drink and how much was the popcorn. So we could find both, but that's not what this one is asking for. So let's set this up. One, we need two different variables. What two variables do you want to use? B for bags of popcorn, okay. Now would this represent the number of, the cost of? What don't we know? How much is it? So this is going to be the cost of the bags of popcorn. And then what do we want our other variable to be? F, okay. And that would be for the cost of the fountain drinks. Alright, so we have variables. Now we can set up two equations, or set up a system of equations. How do you think those two equations are going to be written? How would we set up those two equations? Or let's set up one. How do you think one of them is going to be set up? Are you doing the first set or the second set? Okay, so 3B somehow, somewhere in that we need F. For F, what are we doing to 3B and 4F? We're going to add them because we're really looking at the total cost. And that's going to equal that total cost of $22.50. So if you don't have your calculator, you need it. Let's set up the other one. What would the other equation look like?
2b plus 5
Equals
23.7.
right. So we set up our variables. We now have a system of equations. Now we need to solve them. So it's asking for how much is a fountain drink. And I'm going to show you a trick to solving these. If it's asking for one thing specifically, solve for the other. That way it ends up with what you really want. That's confusing, but let's try that. So right now we only know one way to solve. Later you will find out others, and then you will be able to pick and choose whichever way you want to solve this. What is our first step to solving systems of equations? You can look at the first page of your notes. So substitute is the second step. So it does say solve for x or y. Now we don't have x or y in this, but we can pretend that b is x and f is y. So we need to solve for b or f in one of these two. Since we need to eventually find the cost of the fountain drinks, we're going to solve for b first, and it will help us find f. Does not matter which one. These don't have anything isolated, so it's a little bit harder, but it's going to work out the same way. So let's do this one. I'm going to solve this for b. How would I solve this equation for b? Subtract 4f, so I'm going to rewrite it down here. Remember that these are not like terms, so you should not be combining. I'm going to try really hard to make this b look like a b and not a 6. Right, and then what? Not subtract 3, but divide 3. So in your calculator, I need you to figure out what 22.5 divided by 3 is. $7.5 minus, I'm going to leave this as a fraction only because this is going to be some repeating decimal, 1.333 repeating. So we now have an equation solved for one of the variables. We've done step 1. Step 2, substitute this equation into the other equation. So not the one we took, but the second one. So we're going to put this in for b. This process is going to be lengthy and time consuming for a while until you get the hang of it. So 2b or 2 times all of this. 2 times 7.5 minus 4/3 f plus 5f equals 23.75. Now, remember when I said whatever it's asking for, solve for the opposite and you will end up with what you need. So we solved for the bags of popcorn, but when we substituted, we got just f's. And that's what we need. Now, that doesn't mean if you solve for the other thing, it won't work. You'll just have more work to do. Right? We need to distribute. 2 times 7.5 is 15. I'm going to leave this in fraction form just for right now. This will be 8 over 3f plus 5f equals 23.75. Now when we combine these two, go ahead and do that in your calculator. Leave this as a fraction. Negative 8 over 3 plus 5. What is that? Negative 8 over 3 plus 5 is 7 over 3. Or 2 1/3, or 2.3 repeating. Okay. Now we need to subtract. So the process is still the same even though we have these ugly fractions and decimals. We have to be careful. What would this be? 23.75 minus 15. 9.75. And then how could we get rid of this 7/3? What did you say? You could do that, yes. You could turn it into a decimal, but then you have to use all of the decimals. How else could you get rid of 7/3? So normally, yes, when we have two things multiplying, we divide, but we don't really like dividing by fractions. So how do we get rid of the fraction? Chris? Yes. So if we multiply both sides by 3/7 instead, it would be the same thing as dividing by 7/3. So in your calculator, do 9.75 times 3/7. What do you get?
We had to find fractions again.
Alpha what equals?
4.17.
Was that rounded?
Oh yeah. Or 1. 8.
What were all the numbers?
178.
Yeah, so 17 or 18. So that just means about. So you have to think realistically. This is talking about something you buy. When you buy something, there's maybe 2 cents or 2 decimal places after it, not 15 or 10 or whatever. So you're going to have to round that second one. So that means the cost of a fountain drink is $4.18. Now, if we wanted to, we could go and we could find the cost of the bag of popcorn. But it did not ask us to do that, so we do not need to do that.
I'm pretty sure it was 8.75.
8.7 instead of 9. Okay. I was going to say something that's a little off. We should change this to what?
I know it's 20.6.
It shouldn't be that high. Because remember, the total is like 23. What do you
I was just gonna ask if I could do that in votes.
got? 3.75. That's right. Exactly, or was that rounded?
Exactly.
Now, the good thing about this is that it's a maze, so we kind of know our possible answer choices. It had to be 250 or 375. I will in 1 second. So I know this process is long, and there were problems, and no one likes them, and it's boring. But we gotta do them. So on to the next piece of this. So now we're here. Ryan works at the donut shop where he makes $10.25 per hour. He also works part-time at the school bookstore where he makes $8.75 per hour. If he worked 20 total hours last week and made $196, how many hours did he work at the bookstore? What's important? Okay. The how much he makes. I guess that doesn't really matter which color I do. I was trying to be consistent. So $10.25 at the donut shop, $8.75 at the school bookstore. What else is important? The 196. So the total amount he got for both. I need to start using that color. the total amount of hours he worked. And then what are we looking for?
How many hours?
How many total hours, or how many hours did he work at one of the specific stores? So this one's going to be set up a little differently than what we just did. First, let's define our variables. Okay, so, but we have two different amounts of hours. Hours at the donut shop, hours at the bookstore.
So at the donut shop, then Y for the book.
Okay, so yes, remember we can always use X and Y, but if you want to be specific, if you want to say D and S or whatever, you can do those too. So X is going to be the number of hours at the donut shop. I'm just going to leave it at donuts. And then Y will be the number of hours worked at the bookstore. So the reason I said this is going to be a little different is because before we had a number of fountain drinks, a number of bags of popcorn, a total, and then the same thing for the second one. This one, not so much. We have the amount he makes at one store, the amount he makes at another store, the total he made for both stores, and the total number of hours he worked for both. So we have to kind of combine these. Anyone want to take a guess? Yes.
It's like 10, 25, X plus 8.75Y equals.
So this one's not going to equal 20.
Oh, we have the hours plus. Equals 196.
It'll equal 196. So this, if we knew how many hours he worked at both, we could find the total amount he got or earned, which was the 196. Now, we know that the total number of hours he worked was 20. And we know X and Y are the number of hours he worked at both. How could I use X and Y for the second equation? I'll give you a hint. You're not going to use those numbers again.
Have X plus Y equals 20.
Just X plus Y equals 20. I don't know why I did that so far over. So some of them you have to think about what exactly am I setting up. Some of them are going to be set up much differently than others, and you have to pay attention to how. Right? So it's asking for the number of hours he worked in the bookstore. So it would be beneficial to us to solve for that number of hours he worked at the donut shop. That way when we go to solve it, it kind of works itself out. So let's solve for X in this case. And because these are both isolated, I'm going to use this one. How would I solve for X here? How would we get X by itself?
Subtract Y.
Subtract Y on both sides. Okay, now we have X by itself. What are we going to do with it?
Take it
To where?
the way this is 10 plus 25.
Correct. So 10.25 times whatever x was, 20 minus y, plus 8.75y equals 196. And then we just need to solve. This will probably be the last one because this one's kind of good. 10.25 times 20. $205. No decimal. Minus 10.25y plus 8.75y equals 196. Negative 10.25 plus 8.75 is what? Negative 1.5. So 205 minus 1.05 or 1.5. 1.5. Sorry. Y equals 196. And now we can subtract. $196 minus 205 is -9. Now, I want you to look at this really quickly because we have two negatives, so it's going to work itself out. If you're solving word problems and you end up with one negative sign, you did something wrong. Because real world problems can't be negative. You can't have negative apples, negative people, whatever. You can't have negatives. So either you need two negatives or you forgot it somewhere. Just make sure you're double checking that. What is negative 9 divided by negative 1.5? So 6 is the number of hours he worked at the bookstore. When we were looking at this, we could have really canceled this one out because we can't work $3.29. That doesn't make sense. So next class we're going to continue this. If you want to work on ahead, you may, but I'm not asking you to.